A warm greetings to the CEO's participants. I'm Ratheesh from Space Applications Center, India, and I will be briefing you on the CEO's product, that is the bathymetry for Bay of Bengal, its use and the brief methodology involved. As we know that coastal regions are highly dynamic in nature, and the sediment input from river form the nearshore bathymetric features that are basically transient. They change their morphology and orientation under the influence of the prevailing hydrodynamics of these regions, and these changes are critical in particular to the maintenance of navigational channels. The bathymetry form a key component for other applications like modeling coastal hydrodynamics and storm surge inundations. It has its significance in habitat monitoring, basically for the benthic organisms, and monitoring the coral reef and its health. The information on bathymetry is also vital for monitoring the coastal erosion and in other development activities like marine installation, placing of the pipeline, sewage, and other effluent discharges. The Bay of Bengal have a large sediment input from major rivers along its eastern and western boundary. The east coast is in particular subjected to frequent tropical cyclone and are highly eroding coast. The coast of Bay of Bengal also have several vital habitats like mangroves and nesting grounds of various endangered species that makes the region significant to be monitored. You can see in this figure that the bathymetry are steep along the western boundary of the bay, and to the north there is the Ganges fan, which is the largest submarine fan. If we see along the delta region in a large scale, we can see a complex bathymetry with intricate tidal channels and depositional features. There are various remote sensing techniques to derive the coastal bathymetry. Basically, optical images and LiDAR are the techniques that are used to estimate the coastal bathymetry. But along the regions with high sediment input from river, the optical and LiDAR fails as the turbidity prevents the light penetration. While the synthetic aperture radar sees the manifestation of the surface flow due to the change in the bottom topography. As the slope changes, the sea surface roughness changes that induce a change in the backscatter, which results in a pattern on the SAR images. As you can see on the right hand image, the bathymetry of hydrographic chart and the Sentinel-1 SAR image is shown for Hooghly Delta, which is basically in Bay of Bengal. Now, the features or the backscatter pattern coincide with the bottom topography. The depositional features are basically transient in nature, and the SAR images are used to estimate the updated bathymetric value. The radar backscatter model is used to estimate the sigma naught using the auxiliary parameters, and iterations are carried out by changing the slope to match the observed sigma naught. Thus, the bathymetry of the features are estimated, and we can see that the features are highly dynamic in nature. The rightmost panel shows the difference between the SAR derived and the hydrographic charts, where we can see the deepening of the channels and deposition along its side. So in the COS product, basically the bathymetric product shall be an updated bathymetry in a complex regime that can be used to accurately model the coastal hydrodynamics and predict the coastal inundation during a cyclone activity. Thank you.